All right, guys, so we're going to take a look at a MATLAB simulation for torque vectoring. And in this situation, we're going to pretend that there's an obstacle on the road, okay? So this actually represents the steering input of the driver. So initially, he's going on a straight line. Then he sees the obstacle, so he decides to switch lanes and try to avoid that obstacle. So by doing so, he turns the steering wheel to the left. So that's what is represented here. Then at the top, he decides to try to straighten the car. So that's represented by the downward path of the curb. And then finally, it stabilizes to go back on the straight path. But then he was on the right lane, so he decides to switch back to the right lane. So that's why it's actually the opposite of when he was going towards the left. And then again, it stabilizes at the end here when he's going on a straight line. Then here, what we have is actually the yaw rate, which is actually represented with two curves. So the first one is the blue one, which is actually the desired yaw rate. And the green one is the actual yaw rate. So there's actually just a difference of about 1 second between the two. But other than that, you see that it's very similar. So the controller actually does the job quite well. And finally, here we have the torque transfer. So the torque transfer is actually the opposite sign of the desired input. So the reason for that is because as you're turning your steering wheel towards the left, the transfer is actually being done towards the right tire. So by doing so, it has the opposite sign. So that's why here it's negative, and then it stabilizes again, and then it becomes positive here, as opposed to, again, the desired input.